Hi everyone. Good evening all of you. Good evening guys. How are you all? Audio, video, both are clear everyone? All of you. Right. Audio clear or not? Somebody? Right. So here we'll be going for discussions on this quick revision of this highway engineering. Right. Wherever we have stopped, right, we'll be continuing from the part. You can see now. Rishikesh, good afternoon. So lunch gets over everyone? All of you lunch gets over or not? Right. So here over now. So this is a highway quick revision series we are doing now. So this highway quick revision series we are doing, right? Lunch over? Very good. So now we'll be going for which one? We'll be going for which one you consider? We'll be going for this highway materials, right? Because all the discussions of this which one gets over, you can say, if you just observe, all the discussions of this geometric design gets over, na? Yes or no? All the discussions of this geometric design gets over, right? Now we'll be going for which one? This that vertical alignment valley curve. Valley curve gets over or valley curve is not over till now? That valley curve gets over or valley curve is not over? Tell me. Is that valley curve fully over? Right, valley curve is a little bit pending it seems, right? So all of you, welcome to Unacademy. Let's crack it, right? So get ready to crack all of you. So this is my profile, you can follow me, and this is the referral code. RP Civil is the referral code you have to use. These are all top 7 rankers, sorry, AIR 1 rankers from Unacademy in GATE 2024, right? Right. So these are the Ummeed batch, right? Ummeed batch for this 2025 will be starting on March 30th, all of you. And also which one? This is Sangram batch for this 2026 also will be starting on this March 30th, right? Today, Jaspal sir will be starting with the fluid mechanics, right? And tomorrow will be the last date for this offer, right? So it is extended a final time. So one more time it is extended finally. Beyond this, it will never be extended, you can say, all of you. So this 50% off on your subscription. At GATE 1 year subscription you can get for what? Half of price, right? 19,999, right? What is that code you have to use? If you just observe, RP Civil is the code you have to use, you can say, okay? So this is placement batch will be starting on 30th March for this is whenever you are having a doubt which one to be selected and which one to be recommended, you check these are all the books you will be getting printed to your home delivered, printed and delivered to your home within this 15 days of your subscription, right? If you are taking only iconic subscription, right? So this no cost EMI option is available, and these are all plus subscription features. These are all which one? This iconic subscription features along with the plus features, right? So whichever is suitable, you just recommend that to your friends, juniors and everybody, and you chose that, right? Now coming to this, where we were discussing, right, which part we were discussing, if you just observe, we were discussing about this highway that valley curves part we were discussing. If you just observe, right, valley curves part only we are discussing, everyone. So in this valley curves, what is that you can say? So this valley curves, right, the different combinations of these gradients gets over, right? Criteria for design, shape of this valley curve over, length of this valley curve over, right? Yes, now what is it you can say? Impact factor, that's it, right? Up to that point it gets over. Now we'll be going for this quick revision of which one? This highway engineering. This highway materials, right? Before we go for this highway materials, right, first what we'll do? We'll finish off this we'll finish off which one you can say, right? We will finish off this, right? We will finish off this, which one you can say? We will finish off this valley curve, if you just observe, right? Okay, so there are little bit things left in this valley curve. After these are over, we'll be going for which one? This materials, you can say. Okay, now how many points got over? 139 points got over now. So this is your today's first slide, 140 point. So what is that 140 point? You can see, if you just observe, whenever it is for this symmetrical, whenever it is that is symmetrical, right, that valley curve got to be symmetrical, na? For this vary curve got to be symmetrical, what is the condition to, you can say that a reduced level of this first tangent point will be equal to that reduced level of this second tangent point. First gradient n1 will be equal to that second gradient n2, you can say, is not? Now, and what else you are having the condition? And for unsymmetrical, if you just observe, whenever it is your unsymmetrical value curve, right, what are the conditions to be satisfied? Tell me. For this unsymmetrical value curve, that a reduced level of this first point and this reduced level of this second tangent point will be same or need not be same? Tell me. They need not be same. No? This is your symmetrical value curve, because right, this is first tangent point, this is your second tangent point, you can say. What is this? This is your point of vertical intersection, right? Is not? Now unsymmetrical curve means it will be like this. Let us say, just for an example, this is your first gradient n1 here, this is your second gradient n2 here, right? So this first tangent point and second tangent point both are at the same level or not at the same level for unsymmetrical? For unsymmetrical, both are not at the same level. So this is n1 will not be equal to which one? This n2, you can say, right? Now 141 point. What is the next point? You can say location or this distance of which point, you can say location or this distance of this point of vertical intersection from where? Location or this distance of this point of vertical intersection from this first tangent point, and from where? And from this second tangent point, right? What is it? You can say it will be how much? You can say, if you just observe, this will be same L/2 only for both. Which one? This is L/2 only for both symmetrical as well as this unsymmetrical value curve. LV/2, yes. What is it? LV? Length of this value curve, right? For symmetrical as well as which one? Unsymmetrical value curve, right? It is valid for both, na? If you just observe, this is your center. So what is this? This is your LV/2. And what is this value, right? This is also which one? You can say, right, that is your LV/2, na? So from this first tangent point to this one, right, that is your LV/2. And from here to this is second tangent point also, right, what is it? You can say that is your LV/2, you can say. Got it? This is your point of vertical intersection. Okay, right? Clear now? Now this and tell me, we'll write more on the next one then, or we'll write here itself. .142. So I'll be writing that here itself, right? Location of which one? Location of this deepest point, or you can also call it as which one? This lowest point, na? Location of this deepest point or this lowest point from where, if you just observe, location of this deepest point or this lowest point from first tangent point, right? What is it? You can say from this first tangent point, it is given with the symbol x1, na? No. So from second tangent point, right, what is it? You can say from this second tangent point to T2, right, what is the symbol we are giving? X2 we are giving, right? That is equal to which one? This LV/2 in case of what? Symmetrical curve. Yes, absolutely. In case of this symmetrical curve, right, that is your LV/2 only. But if it is unsymmetrical, is it LV/2? Here you can say this is your lowest point. Can we say this itself will be x1 and this itself will be your x2? If you just observe, yes, that is x1 and this is x2. Got it? Now here this is your lowest point comes to be, na? So this is your x1 from first tangent point, and what is this, right? From here to this second tangent point, right? That is distance will be which one? That distance will be equal to that x2, you can say. Got it? Clear? Clear? Or this and tell me. Right, done. This is also done. Right. So here, what is that you can see if you just observe next. For unsymmetrical, that is x1 equal to which one? This n1 by this n into what is that you can say LV, and what is that you can say x2 will be equal to which one? This n2 by this n into which one? This is LV. For what? This is for which one you can say if you just observe. This is for which one you can say? This is for this unsymmetrical. This is for unsymmetrical as per IRC, right? As per IRC, that by default value, na, so no default value we have to select it, right? And it is based on which parabola? It is based on this cubic parabola, or it is based on this second degree parabola, square parabola. If you just observe, it is based on this square parabola, na? It is based on this square parabola, right? It is based on this square parabola condition, right? By default. So do you remember that calculation of this lowest point and some length calculations, that these are all corresponding to this square parabola only. Construction and length based on this comfort, these are all corresponding to which one? This cubic parabola you can say. But sometimes if you wanted to use this cubic parabola equation and you wanted to get this lowest point location, and how can you get that? Right? So what is it you can say if we just observe? If third degree parabola or this cubic parabola is considered, what is it you can say? Then x1 will be equal to how much? What is the formula for this x1? Any idea? Yeah, yes, root will come into picture. Yes, that root will come into picture. But what is it you can say? Under root n1 by which one? It is your 2n times LV. This is x2 will be equal to which one? Under root, what is it you can say? n2 divided by which one? This is 2n into that LV. But which one we have to use by default if you just observe? Which one we have to use by default if you just observe? Tell me. Which one we have to use by default? We have to use this first one based on the square parabola only. By default you have to use it, because IRC conditions only we have to follow, or not? We have to follow these IRC conditions only by default, right? So if a specific conditions like this are mentioned, that cubic parabola is used, then only we have to use this, right? Now tell me, what is that lowest point? Lowest point is on which side? You can say it is on the flatter gradient side of this PVI, or it is on the flatter gradient side, right? It is on the steeper gradient side. Tell me. Lowest point is on this flatter gradient side of what? Lowest point is on this flatter gradient side of what? Lowest point is on this flatter gradient side of this point of vertical intersection. Okay, it is on the flatter gradient side of this point of vertical intersection, you can say. Got it? Now, or you can also say it as which one? That lowest point is nearer to which tangent point? Lowest point is nearer to what tangent point? It will be. It is nearer to the tangent point of what? It is nearer to the tangent point of this flatter gradient or tangent point of this steeper gradient. Tell me. It is nearer to the tangent point of this flatter gradient, no? Nearer to the tangent point of this flatter gradient, you can say P just right. Got it now? Clear? Right. So once it is clear, now done. Once not, tell me. Right, done? Yes, yes, over. Your lunch gets over or not? Right, done. Shall I move on to the next? Right, so now we'll be going for which one? This is the highway materials, right? This 13th chapter, right? What is it? We'll go for highway materials. Okay, morning only, lunch, breakfast, everything is over. Very good, very good. Right, this is your second slide, no? Third slide, we can write it. Okay, what tell me? The setting is made. How to go with this actually? Shall we go in this? First, shall we go for this soil? First, shall we go for this soil, or first we'll be going for this mix, bituminous mix? Tell me, which one you wanted to go for? First, shall we go for this bituminous mix or soil? Which one you wanted to go? Which one you wanted to start? Tell me. Shall I start this bitumen? I think soil. Okay, we'll start this soil then. Okay, we'll start the soil then. Right, highway materials. Right, highway materials. Right, what is it you can say? First one is subgrade soil. How many points gets over if you just observe? Sorry, 143 points gets over, na? Listen, tests on soil. Aggregates, why? So aggregates will go for later. Tests on this is subgrade soil. Okay. No. So first you go for this CBR if you just observe, right? Now 143 points gets over, na? This is your 144 points. Now tell me, you'll be going for which one? This is testing, right? You'll be taking this soil sample and you'll be applying this load, na? Yes or no? So this is your which one you can say? So here this is your soil sample you are filling. Yes, no? This is your soil sample you are filling, and what is that we are doing? If you just observe, we'll be applying the load through this plunger, na? Yes, no? We'll be applying load through this plunger or not? We'll be applying load through this plunger, you can say. What is the diameter of this plunger, you can say? That is your 5 centimeter or 5 millimeter diameter plunger. Tell me. That is your 5 centimeter or 5 millimeter diameter plunger, right? Which one? Tell me. At this bottom we will be having, okay, one second, 5 centimeter diameter plunger, na? It is. So this is your which one? This is a 5 centimeter diameter plunger, right? What is the soil, you can say? This is your soil sample, right? Sieved through which one, you can say? It is sieved through which one, you can say? That soil sample size is what? Passing through 20 mm, na? Is that no? Passing 20 millimeter or not? Yes or no? Passing 20 millimeter, you can say, right? Now how can you get that CBR 2.5? You just observe, CBR 2.5 will be equal to how much? This 5 is not there. Okay, CBR 2.5 is equal to, how can you get that if you just observe? That is nothing but your load corresponding to this 2.5 millimeters deformation on which one, you can say, on this soil, na? Yes or no? Divided by load corresponding to which one? This 2.5 millimeter deformation on which one? This standard crushed aggregate, na? On this standard crushed aggregate or not? On this standard crushed aggregate into 100, you can say, right? Got it? Standard crushed aggregate into this 100, you can say. If you just once sieve, yeah, sieve size passing through 20 millimeter, right? Passing 20 millimeter sieve, right? And written on which one? Passing through this 20 millimeter sieve, isn't it? Written on 4.5. Okay. Now if you wanted to get this CBR 5, what is it we need to go for? Load corresponding to this 5 millimeter deformation on this soil, you take it, divided by this load corresponding to which one? This 5 millimeter deformation on this standard crushed aggregate, right? It's not like that, you have to take these. Now how can you get that, right? This is your load in kg on this vertical axis, load in kg in this vertical axis, and this deformation delta in which one? This millimeter we have to get it now. Yes or no? Now here if you just consider, what is the curve you will be getting, right? You will be getting the curve like this now. Yes or no? You'll be getting curve in this manner or not? You'll be getting curve in this manner, you can say. So what is it you can say? Corresponding to this 2.5 millimeter deformation. You'll be getting this load value as which one? This, that is your P2.5. And similarly corresponding to this 5 millimeter deformation, and what is it you can say? That is your load corresponding to this 5 millimeter deformation, right? Yes, no? Got it? Now, after this, right, what is it you can say? This is how we'll be getting the CBR. Okay? Suppose if that CBR 2.5 is greater than this CBR 5, what is that we need to do? We need to accept the test results, or we need to accept the test results, or we need to reconduct the test. Tell me. We need to accept which one? We need to accept the test results, or we should proceed further? Yes, we have to accept. No? Accept the test, right? Suppose if that CBR 2.5 is lesser than the CBR 5, right? What is it you can say? We need to accept the test, or we need to repeat the test. Tell me. We need to accept the test, or we need to repeat the test, right? We need to repeat the test under this condition. Yes, or we need to repeat the test under this condition, you can say. Finally, which one is taken as the CBR of this soil? CBR of this soil, you can say. Finally, what is it you can say? That is CBR of this soil, right? Which one we have to take it? CBR of this soil will be taken as this higher. Higher of what? Higher of this CBR 2.5, and which one this is CBR 5 now? Among these two, right? Whichever is higher, right? That only we have to take it, right? Like that. Is it clear? Is it clear now? Which one is higher? Tell me. Right done? Clear? Right done, everyone? No. Here, what is another one? You can see if you just observe. Here the specifications, if you see. What are these specifications? You can say it. What are the what are these specifications? You can say if you just observe. We have to follow here. The specifications will be what? Tell me. Specifications will be what? What is it? Rate of loading. Not loading, loading. What is it? A rate of loading, you can say? Anyone tell me? Rate of loading will be what? What is it? How much? How many millimeter, right? Yes, 1.25 millimeter per what? Minute, right? 1.25 millimeter per which one? This is a minute or second? 1.25 millimeter per this minute, or this is second, you can say if you just observe, right? That is your 1.25. What is it you can say? 1.25 millimeters per minute, you can say, right? 1.25 millimeters per this minute, you can say if you just observe, right? And what is it you can say next? What is the surcharge loading we have to go for? How much is the surcharge loading we have to go for? What is the surcharge loading we have to go for? It will be taken as which one? This is a 10 kilometer, right? So 10 kilometer for which one? 10 kg, not kilometers. 10 kg for which one? This is 25 centimeter thickness. 25 centimeter thickness is there, na? So then it will be 10 kg you have to take it, right? 10 kg you have to take it, right? and the soil is soaked in the water for how many days, you can say? That soil directly which is taken from the field as it is, we have to conduct the test, or we have to soak it in water? Tell me if you just observe. We have to soak it in water, definitely. Now how to soak it? How to soak it and where to soak it? Tell me. Water, no? Soil soaked at which one? 95 to what? 95 to this 100% of this optimum moisture content in water, na? Is that no? For how many days? For how many days we have to soak it? For this 4 days we have to soak it, na? For this 4 days we have to soak it, if you just observe, right? Is that right? And now tell me, it is a it is which strength test me? Tell me, it is a field test or it is a lab test? That CBR test. That CBR test will be your lab test, na? And it is exact test or it is an arbitrary strength test, you can say. It is an arbitrary strength test, na? It is an arbitrary strength test. And are you representing the strength exactly, or we are comparing the strength of this one with the strength of this standard crust aggregate? We are comparing the strength of this one with the strength of this standard crust aggregate, na? So what is it you can say? And the relative strength representation. Okay, the relative which one? Comparative or this relative strength? Relative strength representation, if you right? Relative strength representation, if you just observe, right? What is that relative strength representation, you can say? That is relative strength representation means what? So this is comparing, in this formula, load on the soil for 2.5 mm deformation divided by this load on the standard crust aggregate. Now what are these values of this load on the standard crust aggregate, you can say? Corresponding to this deformation in millimeter, load on this standard crust aggregate in kg, and you can say, what is it you can say? Pressure on this standard crust aggregate, you can say. Why pressure also? Because same plunger diameter. What is the diameter of this plunger? I have to write it here, I forgot. Right, the specifications. What is the diameter of this plunger? Tell me. Plunger means that a loading element, na? What is the diameter of this plunger? We have to use it. 5 cm diameter plunger we have to use it, na? Now, what is that? Delta in millimeters, 2.5 millimeters. This is 5 millimeters. So what is that load corresponding to this 2.5 millimeter deformation? How much it is? It is 1370 kg, na? Next, what is it you can say? One 1370 kg, 2055 kg, na? And whenever you are applying this pressure at 1370 divided by this pi by 4 into the 5 square, what it will become? 70 approximately. Which one? This 70 kg per this centimeter square or not? Now, this is approximately, right? What is it you can say? 105 kg per this centimeter square, na? But when we have to use this formula? When we have to use this? When this numerator that load on the soil obtained is as the pressure, denominator also we have to use it as the pressure, you can say. Got it now? Denominator also we have to use it as the pressure. Right? Got it? Clear? Clear, everyone? Right, done? Others also? Now, next test, right? What is the next test on this soil we have to go for, if you just observe? What is the next test on this soil we have to go for, if you just observe? That is your plate load test, na? This is your CBR test, you can say, right? But Okay, shall we go for this which one? Reduction. One 46, 147. So what is it you can say? If initial concavity is present, it will be taken as it is or it has to be modified, tell me. It will be taken as it is, right? Initial concavity is there, right? We have to modify it. If you just observe, we have to modify if the initial concavity is there, na? Yes or no? Initial concavity, na? Yes or no? Right? Hello, we have to modify or we have to keep it as it is, tell me. Yes means what? Modifying or keeping as it is? Yes means what? Modified, right? We have to modify it definitely, na? Yes or no? We have to modify it definitely or not, right? We have to modify it definitely, you can say, is not? We have to modify definitely, right? Because the initial conditions, initial concavity does not represent which one? This original behavior, you can say, right? This is your load and this is your which one? This deflection curve. Suppose if you are getting like this, one sec. This is your initial concavity you will be having, yes or no? This is your initial concavity you will be having, yes or no? That is your initial concavity, na? Yes or no? Initial concavity rate, what is it we need to do? How to modify it if we just observe? How to modify it, tell me. We need to identify. So from this point onwards, what happens? It becomes convex, na? Yes or no? So this is your first point of this convexity, right? Draw a tangent to this point of this first point of this convexity. Then that tangent is intersecting. Right? This is your new original origin and this is your new origin. Na? So we have to consider which portion if we just observe. We have to consider which portion. Up to this we have to consider this portion only. No? Like this we have to modify, right? Up to this rate, what is it you can say? We have to take this portion and after that we have to take that portion. And this portion we have to take it and this portion we have to take it, right? This original portion we need to take or we should not take the original portion, tell me. We should not take the original portion, na? Zana. Right? So this is corresponding to which one? This CBR test. Is it clear? Any doubts in the CBR test? Right. So which test will be going for? Tests on this soil, right? Which test we have to go for? Which test we have to go for? That plate load test we have to go for, na? Plate load test we have to go for, right? 147th point over, na? This is your 148th point. Okay. Now tell me, right, how much it comes to be if we just observe. how much it comes to be? What is it? This is plate load test is a lab test, or plate load test is a lab test, or it is a field test, you can say. It is a lab test or it is a field test? Tell me that plate load test, everyone. It is a field test, na? So no, it is a field test, you can say, if you just observe, right? It is a field test if you just observe, right? So first, shall we write these points? Okay, shall we write these points, whatever it is? Okay, it is a field test and it is your a rational or not? It is a field test and this is a rational test, na? So it is a field test, and which test you can say? It is also the rational test, you can say. What is the meaning of this rational test, you can say, if you just observe? Rational test means it is a strength test, na? Sorry, strength test, or it is a stiffness test, if you just observe. It is your stiffness related test, na? What is the meaning of this rational test, if you just observe? What is the meaning of this rational test, you can say? Rational test means are you changing the field conditions when you are testing, or we are keeping the field conditions as it is not? Right? Yeah, it is on this undisturbed soil, na? Test on this undisturbed soil, you can say. Yes, that point also we can write. Test on this undisturbed soil, if you just observe. Yeah, as it is undisturbed, right? As it is undisturbed, you can say. Generally, at which location will be conducting? Generally, at this which location it will be conducting, you can say. Generally, at which location it will be conducted? Exactly on the ground, or we have to conduct this at which one? At some depth. At some depth, na? At which depth we have to conduct, you can say? At which depth you have to conduct, you can say? At this below the ground surface, right? At least 500 millimeter below we have to construct, na? 500 millimeter below we have to conduct this test or not? So this is your plate, a circular plate will be keeping, and this hydraulic jacks and everything will be keeping. What is the symbol we are giving for this diameter of this plate, right? Phi. What is the symbol for this radius of this plate? A, you can say. Got it? So we'll be having this sand bags, aggregate bags, right? Whatever is the bags you are having, you have to use it, right? And we'll be measuring which one, this deflection also with this, no? Deflection also can measure, right? Probing ring will be there. That probing ring will give the distances, right? Probing ring will give the distances, and what is it you can say? This dial gauge will give the deflections. The dial gauge will give the deflections, you can say. Got it? Clear now? Now, how can you get that? 149th point. What is that modulus of subgrade reaction, you call it as, na? What is the name you give for this parameter? Modulus of what? Modulus of this subgrade reaction. So what is the modulus of subgrade reaction? You can say that modulus of subgrade reaction or stiffness of this soil, na? What is the symbol we are giving for this stiffness of this soil? Tell me. What is the symbol we are giving? K is the symbol we are giving for this stiffness of this soil, na? So no, K is the symbol we are giving for this stiffness of this soil, if you just observe, right? K is the symbol we are giving for which one? Stiffness of this soil, if you just observe, you can say. Got it? Now, how can you get that K value? Tell me, anyone? Anyone? The expression for this K value will be what? This is your pressure P divided by how much, you can say? That is your pressure P divided by this delta, you can say, if you just observe, right? Pressure P divided by which one? Delta deformation, if you just observe, right? That is what. So what is the unit of this K? Unit of K will be that kg per this centimeter square, na? So no, kg per this centimeter square, and kg per this centimeter square, right? What is the delta? You can say that delta is in centimeters, And what is the pressure P? It is in kg per this centimeter square, na? But do you give guarantee that do you give guarantee that same pressure only will be possible and same deformation only it will be possible? Tell me. Is it? Is it possible to maintain or it is not possible to maintain? Tell me, right? It is not at all possible to maintain, na? So no, it is not at all possible to maintain or not? Yes, it is not at all possible to maintain, right? Steel structures, actually I'm doing that at different time now. 4:15 p.m. I'm doing that now, right? Uh, okay. This is k value kg per centimeter cube, because p is kg per centimeter square, this is centimeter, so kg per centimeter square per centimeter, kg per centimeter cube, right? Okay, don't worry, I'll continue that, right? That series also will be continued, right? No need to worry. That series also will be continued, right? There is nothing to worry about it. Okay, right? But only thing is time difficult, actually. Time tightness will be where, yeah. Steel also, there you can get links. Where you can get these links? Yeah, in the groups you can get these links, right? Yes. No. Today we don't have that, because today we'll be having this plus class. Today we don't have. I'll try to take it at which one? This is tomorrow 10:30. I'll take it, because previously up to 10 o'clock only plus class was there, Vaishali. Now plus class is there up to 10:30 now. 8:30 to 10:30 gate plus class is there. So that is why I have a little bit delayed that. Tomorrow I'll try to take it some other time. Okay. At least at 10:30 I'll try to take it. Okay. Now here what is that we have to take it, that k value, that stiffness will be equal to which one? That stiffness k will be equal to which one? This we have to take the standard pressure only. Sorry, we have to take the standard deformation. How much you can say? 0.125 centimeter we have to use it. Corresponding to that we have to take the pressure, right? Corresponding to that we have to take the pressure, you can say. Got it? This is your old method or this is your new method? Tell me. That is your old method, na? Now k will be equal to modified method. What is it? They have taken 0.7 kg per centimeter square pressure. 0.7 kg per centimeter square divided by which one? This is the delta we have taken, right? So I think recently also one class I have done. Yesterday or day before yesterday? Day before yesterday it seems I have done one class. Right, what is this? This is your modified method or this is a new method? Na? Yesterday? Yeah, I forgot. Okay. Modified method, right? So that also, that will be continuing, don't worry. So that tension members, only which one is completed? Only that eccentric connections gets over, na? Yesterday. So tension members, we'll start discussing that quick revision, don't worry. Live test also will be doing again after that. Today or tomorrow at 10:30 I'll do it. Tomorrow at 10:30 p.m. I'll try to do that. Okay. Or 11 a.m. any other time. Tomorrow I'll do it. I'll do that definitely. Okay. Tomorrow I'll do that definitely. But I'll just check the times, which time is slot is free, and I'll do that. Okay. Modulus or subgrade reaction will be getting like this. Okay. Now tell me, 150. Generally, whenever it is which one, this subgrade reaction, modulus of subgrade reaction, or the stiffness of this soil means, which value we have to report? This is your pressure P in kg per this centimeter square, na? And this is your deformation delta in centimeters. You can say, if you just observe. Now how the curve comes to be, right? This is how the curve comes to be. You can say, right? This is your 0 if you just observe. Next, what happens? Old method, as per this old method, right? What is it we are doing? This was your 0.125 centimeters, na? And corresponding to that will be going for this pressure, right? Now recently, what is that modified method? This is your delta, and corresponding pressure will be that 0.7 kg per this centimeter square, right? Got it? Now here, if you are using, right, suppose if you are using different, suppose if you are using, you can say, what is it you are using? Suppose if you are using this different plates, right, what happens? You can say, For a different plates, you'll be getting the same K value, or this different K value you can say for a different plates. If you just observe, for a different plates, you'll be getting this different K value, no? Different materials if you are using, different materials if you are using, right? What is it you can say? Different K value, and different diameters also if you are using that different K value, no? So then which one we have to take it finally? Which one we have to take it finally, you can say? Which one we have to take it finally if you just observe? Which one we need to take it finally? We have to take this K of this soil, right? Modulus of subgrade reaction of this soil will be equal to, what is it you can say? Modulus of subgrade reaction of this soil will be equal to, what is it you can say? Modulus of subgrade reaction of this soil will be equal to, that is your K corresponding to which one? This is 750 millimeter, right? 750 millimeter dia, mild steel plate, na? 750 millimeter dia, mild steel plate, you can say. Got it now? Isn't it? 750 millimeter dia, right? 750 millimeter dia. Which one? This is a mild steel plate. We have to go for, if you just observe, right? So suppose if other diameter plates are given, right? What is that we need to do? We need to take these values as it is, or we have to convert them if you just observe. We have to take them as it is, or we have to convert them if you just observe. We have to convert, na? So no, we have to convert from which one? These other we have to convert from which one? These other values, right? How to convert them? Tell me if you just remember. There must be some conversion factors we should have, or not? There must be some conversion factors we should have, right? How can you get these conversion factors if you just say for other diameters, right? So here for other diameters, this is 151 point, you can say. Yes. For this other diameter plates used, so whenever it is that other diameter plates used, what is that you can say? There are different methods you are having now. First one is your old method, you can say. What was this old method, you can say? Old method was this K1A1 equals to that K2A2, na? Equal to so on. Which one? This K75 centimeters, right? K75 means that is your 75 centimeters now. K75 into, right? What is it you can say? Diameter will be which one? This radius will be that 75 by this 2 now. Is that no? Like that. So what is it you can say? K1. What is it? K1? K1 is the stiffness using a plate of how much you can say? K1 is the stiffness using a plate of, right? K1 is the stiffness using a plate of this radius A1, na? So radius how much you can say? Radius A1. Got it? Now what is the K2 if you just observe? It is the stiffness using a plate of which one? This how much radius? A2. Got it now? Clear? Clear? Right. Once clear, note on this. Once note, tell me everyone. I'll move on to this next. New method will go for once it is done. New method. New method means that who gave this method? New method, tell me. IRC 58 has given, this IRC 58 has given, right? So K750 will be equal to K5, means stiffness corresponding to the diameter 5 meter, 1.2 times which one you consider 1.2 times which one 1.21 times this 5 plus this 0.078, right? Is it not the formula? Yes, that is a formula, final formula. Now if you are substituting this K5 in MPa per meter, this K750 also will be getting in which one? This is same units, right? MPa per meter. Suppose if you are taking this in kg per this centimeter cube, then you take this one also as which one? This is kg per this centimeter cube or not? Kg per this centimeter cube, right? Suppose if you are getting this in which units? Other units? Newton per this centimeter cube if you are getting, this also will be getting in which one? This is same Newton per this centimeter cube only. Now what is it you can say? That is your diameter, right? What is the diameter of this plate used? In which units? Diameter of this plate used in which one? This meters, you can say it like that. Got it? Clear? This conversions? No. So what else will be having regarding this plate load test if you just observe? What else will be having regarding this plate load test? You can say? It is elastic modulus, not modulus of resilience, right? Modulus of resilience is obtained from which value? That CBR value of the soil only, no? It is not from this one, right? So it is, what is that you can say? Bose-Nash equations, no? Bose-Nash equations, right? These Bose-Nash equations for what? For which calculations if we just observe? These are for this elastic modulus calculations, no? How can you get that? Tell me. What equations the Bose-Nash fellow has given, if you remember, all of you? 1.18 P into that A by this delta. It is 1.18 or 1.5. We have to take it for the next one if you just observe. Which value? Second value? Visible now? These are 1.5 P into A divided by this delta. Visible, right? Okay. When we have to use this first one, if you just observe, whenever it is this rigid plate or this mild steel plate, by default plate, it is your rigid plate, or you can also say it as which one? This mild steel plate if you just observe, okay? Rigid plate or this mild steel plate you can say, right? And now what is this one? This is for which one? This flexible plate. Or how much it is? It is for this whenever you are using this rigid plate or whenever you are using this which plate? Flexible plate or this rubber plate, na? Why this rubber plate comes into picture? Tell me. Because practically that load will be applied through which one? You can say tires. These tires are made up of which material? These tires are made up of this mild steel, or these tires are made up of this rubber only? Everyone. Hello. Practically the tires are made up of this rubber only. So that is why this fellow Business wanted to create the similar kind of situation. So he said whenever you are using the rubber plate, this is the one we have to use it. Okay. So what is that P? It is a pressure corresponding to a deformation delta when measured using a plate of radius, which one? This is small a. Got it? This is what you are having, and actually if we just write one point now, then it will get over, right? So this soil testing gets over, you can see. One 52 point. 153, right? What is it you can say? Modulus of subgrade reaction for this soaked condition, how much it will be? Modulus of which one? This is subgrade reaction. For which conditions? Tell me. For this is soaked condition. What is the meaning of this soaked condition? When a soil is taken normally directly as it is, or the soil is in the soaked condition present in the field, if you just observe. Because of rain conditions, let us say, whenever rain comes, that entire soil will be subjected to soaking, or not all of you? Hello? The entire soil will be subjected to this soaking or not? Definitely. Yes, that entire soil will be subjected to this soaking, na? Paka? Right? Whenever this is soaking occurs, what is the K? Yes, we have to take it. For soaked condition, Ks equal to that K into which one? This is Ps, Ps by this P. Okay, Ps by Ks or Ps by P it is. K into that Ps by this P is na. What is that Ps you can say? Pressure required for which purpose? Tell me. Ps is your pressure required to create what? Pressure required to create what? Same deflection. Which deflection you can say? Same deflection, right? It is not a reflection, it is deflection. No? Pressure required to create same deflection as of what? So pressure required to create the deflections, same deflections as that of which material? Tell me. As that of what? Okay, we'll write in a different manner. Otherwise, it is to create which one? This is some deflection. Okay, we'll write it in an easy manner. Pressure required to create how much deformation? Some deflection. Okay, some deflection on what? Soaked soil or which soil? On this soaked soil, right? What is it you can say that P means what? The pressure required to create which one? Same deflections. There some, here same. Pressure equal to create this is same deflection. Right? Same means same as the previous now. Same deflection. On which soil you can say, on this soaked soil or on this non-soaked soil you can say. Non-soaked soil you can say. Got it? Clear? PSC is on this soaked soil and P will be on which one? That non-soaked soil if you just observe. Right? Clear now? Once clear, note down. Once note, tell me. Yeah. This is how to apply correction. Huh? So for the same deflection, whatever is the deflection you are taking, you measure this PS for the soaked condition, P for this normal non-soaked condition. Then you will be getting the value of stiffness corresponding to the soaking. Na? Clear now? Everything is clear? Any doubts anywhere? Any doubts anywhere? Okay, I'll be closing the session right. Tomorrow morning 7:45 as well as 2 p.m. right. At both the times we'll be having which one? This highway quick revision only. Okay, quick revision of this highway only we'll be having. So I'll be closing the session. Thank you. Thank you all of you. Have a good day. Thank you.